Always watching Cryptechology. I just want to say thank you for supporting my channel, and thank you for hitting that like button. Hey, what's going on, everybody? It's Simon. So in today's video, we're going to talk about Solana, and I'm going to be doing a video log of my Solana development journey. I've been learning a lot over at Dapp University. As you can see, I completed the blockchain developer bootcamp, and I'm still working on my blockchain mastery university schedule, where we go over so many different topics pertaining to blockchain development. Whether it's layer 2 scaling, compound, setting up your own DeFi savings app, learning how to deploy a Dapp on the Binance Smart Chain, smart contract development with Hard Hat, intro to Uniswap, how to launch your own ICO, creating your own Dapp wallet. I mean, all of that. So I've been, and also, Ethernaut. This was really a fun project. I'm working, not project, but another thing, smart contract security. I would recommend others, if you don't know about Ethernaut, here you can go and learn about a you can practice your skills on smart contract security. So these are all different levels here that you got to go through. So anyone that's interested in smart contract development security, oh, they're hiring. Oh snap! Nice. Maybe I should try to apply. Maybe I should try to apply to that or something. I'm trying to get a blockchain job. As of right now, I'm just very passionate doing this all on my own, learning what I can. Alright, so I don't want to get distracted like in my other videos, so let's stay on track. So Solana, what is Solana? Solana is an open source project implementing a new high-performance permissionless blockchain. The Solana Foundation is based in Geneva, Switzerland, and it maintains an open source project. So why Solana? It is possible for a centralized database to process 710,000 transactions per second on a standard gigabit network if the transactions are, on average, no more than 176 bytes. Now, a centralized database can also replicate itself and maintain a high availability without significantly compromising that transaction rate using the distributed system technique known as optimistic concurrency control, OCC. At Solana, we are demonstrating that these same theoretical limits apply just as well to blockchain on an adversarially network. Adversarially. That's not coming out right. I'm so sorry. The key ingredient: finding a way to share time when nodes cannot trust one another. Once nodes can trust time, suddenly 40 years of distributed systems research becomes applicable to blockchain. So, perhaps the most striking difference between algorithms obtained by our method and ones based upon timeout is that using timeout produces a traditional distributed algorithm in which the processes operate asynchronously, while our method produces a globally synchronous one in which every process does the same thing at approximately the same time. Our method seems to contradict the whole purpose of distributed processing, which is to permit different processes to operate independently and perform different functions. However, if a distributed system is really a single system, then the processes must be synchronized in some way. Conceptually, the easiest way to synchronize processes is to get them all to do the same thing at the same time. Therefore, our method is used to implement a kernel that performs the necessary synchronization. For example, making sure that two different processes do not try to modify a file at the same time. Processes might spend only a small fraction of their time, excuse me, sorry. A small fraction of their time executing the synchronizing kernel. The rest of the time, they can operate independently. Example, accessing different files. This is an approach we have advocated even when fault tolerance is not required. The method's basic simplicity makes it easier to understand the precise properties of a system, which is crucial if one is to know just how fault tolerant the system is. Lampert, 1984. So, furthermore, And much to our surprise, it can be implemented using a mechanism that has existed in Bitcoin since day one. The Bitcoin feature is called N-lock time, and it can be used to post-date transactions using block height instead of a timestamp. As a Bitcoin client, you would use block height instead of a timestamp if you don't trust the network. The block height turns out to be an instance of what's being called as verifiable delay function in cryptography circles. It's a cryptographically secure way to say time has passed. In Solana, we use a far more granular verifiable delay function, the SHA-256 hash chain, to checkpoint the ledger and coordinate consensus. With it, we implement OCC, which is optimistic concurrency control, and are now well en route towards the theoretical limit of 710,000 transactions per second, or 710,000 TPS. Documentation overview. See, the Solana docs describe the Solana open source project, a blockchain built from the ground up for scale. They cover why Solana is useful, how to use it, how it works, and why it will continue to work long after the company Solana closes its doors. The goal of the Solana architecture is to demonstrate there exists a set of software algorithms that, when used in combination to implement a blockchain, removes software as a performance bottleneck, allowing transactions throughput to scale proportionately with network bandwidth. The architecture goes on to satisfy all three desirable properties of a proper blockchain. It is scalable, secure, and decentralized. The architecture describes a theoretical upper bound of 710,000 TPS on a standard gigabit network and 28.4 million TPS on a 40 gigabit. Furthermore, the architecture supports safe, concurrent execution of programs authored in general-purpose programming languages such as C or Rust. So, let's dive some more into Solana. Now, what are some of the terminologies that they use? So, for example, what is a Solana cluster? A cluster is a set of computers that work together and can be viewed from the outside as a single system. A Solana cluster is a set of independently owned computers working together, and sometimes against each other, but to verify the output of untrusted user-submitted programs. Alright, so we're going to do that one more time. So a cluster is a set of computers, okay? They all work together. So when you look at that computer, it looks like just one PC from the outside, alright? It's not going to look like a whole bunch. So for an example, say you have, a bus being pulled, alright? From the back of the bus, you just see the bus movement. But on the other side of the bus, it's attached to a rope that 100 people are pulling that rope, making the bus move. So from one perspective, outside looking in, on the other side of the bus, all we see is that entire bus moving. Alright, so we just see the one unit moving. Alright, but when we actually walk over to the other side, when we actually open up and we do some research to see what's going on, we see that this movement is not just the bus, but it's a group of people working together that's pulling a bus. So a cluster is a group of computers working together, but that cluster, that group of computers working together, is just going to be looked as one item. Okay, it's just going to be looked at as one single system, because it's the combination of everything that's what's being used. Alright, so the Solana cluster is a set of independently owned computers working together. This is collaboration at its core. Alright, this is what blockchain is all about. This right here. We're not competing with each other. It's not about, oh, let me hurry up and try to get mine, and you get yours, da 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 da, screw you, bah. This is, alright, that's your power, this is my power, cool. But if we put our powers together, now we have Super Saiyan mode. You like that? So, alright, so this cluster is the Super Saiyan mode. All right. Solana is the Super Saiyan of blockchains. So we have a group of computers working together to do what? To verify the output of untrusted user submitted programs. All right. So now it's working together to do something, to verify an output. All right, of untrusted user submitted programs. Now, the Solana cluster can be utilized anytime a user wants to preserve an immutable record of events in time or programmatic interpretations of those events. One use is to track which of the computers did meaningful work to keep the cluster running. Another use might be to track the possession of real-world assets. In each case, the cluster produces a record of events called the ledger. It will be preserved for the lifetime of the cluster. As long as someone somewhere in the world maintains a copy of the ledger, the output of its programs, which may contain a record of who possesses what, will forever be reproduced independent of the organization that launched it. Okay, so awesome. So now, what are sols? A SOL is the name of Solana's native token, which can be passed to nodes in a Solana cluster in exchange for running an on-chain program or validating its output. The system may perform micropayments of fractional sols, which are called lamports. They are named in honor of Solana's biggest technical influence, Leslie Lamport. A lamport has a value of 0. How many zeros is that? 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5, 6, 7, 8. All right. 0.801. I forgot how to say that correctly. All right, but that's what it is. Okay. Disclaimer. All claims, content, designs, algorithms, estimates, roadmaps, specifications, performance measurements described in this project are done with the author's best effort. It is up to the reader to check and validate the accuracy and truthfulness. Furthermore, nothing in the project constitutes a solicitation for investment. All right, so terminology. These are the following terms that you're going to use throughout the documentation, and for anyone that's new to Solana, definitely recommend learning this terminology because it is different from other blockchain gigs. However, it is somewhat correlated to old school tech work. So, an account, obviously, is a persistent file addressed by the public key and with lamports tracking its lifetime. You have an app, which is a front-end application that interacts with the Solana cluster. You have the bank state. This is the result of interpreting all programs on the ledger at a given tick height. It includes at least the set of all accounts holding non-zero native tokens. We have block, which is a contingent set of entries on the ledger covered by a vote. A leader produces at most 1 block per slot. We have block hash, which is a pre-image resistance hash of the ledger at a given block height, taken from the last entry ID. We have block height, which is the number of blocks beneath the current block. The first block after the genesis block has height 1. We have bootstrap validator. This is the first validator to produce a block. CBC block. This is the smallest encrypted chunk of ledger. An encrypted ledger segment would be made of many CBC blocks. Client. A node that utilizes the cluster. A cluster is a set of validators maintaining a single ledger. Confirmation time. This is a wall clock duration between a leader creating a tick entry and creating a confirmed block. Confirmed block is a block that has received a supermajority of ledger votes with a ledger interpretation that matches the leaders. Control plane. This is a gossip network connecting all nodes of a cluster. Cooldown period. Some number of epochs after stake has been deactivated while progressively becomes available for withdrawal. During this period, the stake is considered to be deactivated. More info about it at warm-up and cooldown. Credit, see vote credit. Cross-program invocation. This is the instruction called from within an instruction. Put differently, it is how a program calls into another program. Okay, cool. Data plane. It's a multicast network used to efficiently validate entries and gain consensus. A drone is an off-chain service that acts as a custodian for a user's private key. It typically serves to validate and sign transactions. Our entry, well, the entry of on the ledger, either a tick or a transaction entry. We also have the entry ID. This is a pre-image resistant hash over the final contents of an entry, which acts as the entry's globally unique identifier. The hash serves as evidence of the entry being generated after a duration of time. The specified transactions are those included in the entry. And then we have the entry's position with respect to other entries in the ledger. Proof of history. This is another thing I want to get into because this is the consensus. Well, what is proof of history? This is a stack of proofs, each which proves that some data existed before the proof was created and that a precise duration of time has passed before the previous proof. So like a VDF, a proof of history can be verified in less time than it took to produce. And here are some more words. Let's see. Stake is a token's forfeit to cluster if malicious validator behavior can be proven. Tick height token TPS is transactions per second. A transaction, one or more instructions signed by the client using one or more key pairs and executed atomically with only two possible outcomes, success or failure. Then we have the ID, confirmations. VDF is a verifiable delay function, and more. So this is the history. We're not going to go too much into this, but what I do want to go quickly over is how it describes the proof of history, which is a technique for keeping time between computers that do not trust one another. Alright, so that's really important. Reliable clock makes network synchronization very simple. Let me see, what else did I want to say? Oh yeah, this part is cool. So the goal of Solana is to have a TPS, transactions per second, like the fastest in the world. And Bitcoin and Ethereum, they struggled when their network and their community started growing. They struggled to scale beyond 15 transactions per second worldwide, when centralized payment systems such as Visa required peaks of 65,000 transactions per second. Now, without a clock, it was clear they'd never graduate to being the global payment system or global supercomputer most had dreamed them to be. However, when Natalie solved the problem of getting computers that don't trust each other to agree on time, he knew he had the key to bring 40 years of research to the world of blockchain. So the resulting cluster wouldn't be just 10 times faster or 100 times faster or 1,000 times faster, but 10,000 times faster right from the gate. Okay, this is what I'm trying to let you guys know. Yo, Solana has figured out how to scale without getting bogged down, without super high fees, and do it in a way that could seriously improve the efficiency of transactions per second. And the proof of history is just an amazing consensus algorithm. It's fantastic, and honestly, they are on track to become the world's fastest platform for transactions per second. I'm telling you that right now. Solana will become the global leader in TPS. All right, let me say that one more time. Solana will become the global leader in TPS, and this is why, because of proof of history consensus. Alright, y'all, I hope you liked this video. If you enjoyed videos like this, don't forget to hit the like and the subscribe, share this with others, follow along on my blockchain development journey. I'll be making more videos like this as I develop on the Solana chain. Alright, y'all, I'm Simon, this is Cryptechology, and I'll catch you on the next one.